All right, everybody. Hello, welcome to day 2 and stage 6. One more administrative point before we start. Unfortunately, one of our speakers had to cancel today, so the talk of George Hanzaras about empowering platform engineering teams with Kubernetes operators at 2:15 in Hall 4 will be switched to a talk by Thomas Schütz talking about KHGPT. So just if you had the guy on your agenda, please be aware that we had to, he unfortunately is not able to come, so we had to switch it to Thomas Schütz and to talk about KHGPT. Well done. As we had heard in the keynote, there is a lot to learn about eBPF, about service meshes, about the new kid on the block, and that's also what our second speaker here on this stage is going to talk about. We have all the way from Madrid, the founder of Cloud Native Iberia, if I'm correct. I assume?
One of them.
One of them. He's a field engineer at Solo.io. Please give me a hand for Jona Apelbaum talking about the future of service mesh, Sidecarless or eBPF.
Thank you. Thank you, everyone. Another thing, Alessandro, that you see here on the screen, is obviously not here, right? So he couldn't be here today, so you'll have to deal with me. So as was correctly introduced, I'm a field engineer at Solo.io. I do lead one of the organizers of the Madrid Iberia chapter of CNCF, together with Antonio there in the back of the room, and some people from Red Hat in Spain. So please look us up. We have our first meetup the 5th of October in the Red Hat offices in a very high tower, very nice views. So if you want to come down to Madrid, feel free to come over. Cool. We're going to talk about service mesh, Sidecarless, eBPF, or maybe both, right? Who knows? So first of all, who is Solo.io? Who knows Solo.io to start with? Okay, it's not too bad. Okay. Okay, I'll ask another stupid question since you're here. Who knows Istio? Okay, that's a good answer. Obviously, you just heard about eBPF, so I'm not going to ask who knows eBPF, because we just had a talk from Liz about eBPF, but I'll ask the question, who knows what eBPF is? At least people listened. So, good. I'm stressed to talk about eBPF because I got Liz in the room, so I have to be really careful about what I say. Please correct me if I say anything stupid here. Cool. So who is Solo.io? So first of all, Solo.io is one of the main contributors of the Istio project within CNCF. The company has been around for around 5 years. We started with a product called Glue Edge, which was an Envoy-based API gateway, and we evolved to a full service mesh, supporting some of the industry standards like Envoy, Kubernetes, obviously Cilium, GraphQL, and the new kid on the block, eBPF, right? With no further ado, I don't want to talk too much about the company. I'm just going to move ahead, and let's talk about what is a service mesh. Okay, who knows what a service mesh is? If I point one person, I'd love to hear from one person who dares to answer in one phrase, what is a service mesh? Who wants to answer that question? Wow. Okay, cool. So what is a service mesh? Essentially, is how do you drive the behavior between two services? How do you make sure that when two services connect to each other, that one, you secure that connection, right? And two, you can drive behavior in terms of traffic routing, traffic policies, and so on. How do you drive that behavior between two services? And third of all, how do you manage services that move across runtimes, that move across environments? How do you deal with that discovery? How do you connect them to each other? That is a service mesh. Antonio here in the room has a very good description of service mesh. Is if I call somebody on his phone, right? I put his number in. I don't know if that person is here in Australia, maybe in US. All I know, I don't want to call that number. Service mesh is a similar concept. If I want to call a database, I just say, please connect me to a database. I don't know where the database is. I want the system to just make that connection for me in a secure manner, of course. So this is service mesh in a nutshell. How do we implement service mesh? Right? What are the challenges, right, that we saw with service mesh? As I mentioned, service discovery, load balancing, timeouts and retries and things like that. Circuit breaking, tracing, secure transportation, and extensions. So I want to extend the networking, the connection between services by implementing custom filters, by implementing changes that very custom behavior that I want to implement. Cool. How does service mesh work? And Liz touched on it in her keynote. And obviously, this is where the talk is. Classically, a service mesh relies heavily on a sidecar. So every time a part, the thing keeps moving. It's very distracting. So how do I turn this off? 1 second. OK, I think this did it. OK, cool. So how does service mesh work? So essentially, we inject a sidecar into every single part, right? Sure. No, this. Come on. 1 second. Let me just. Sorry for that, guys. Here you go. I went back far. So the way this works is essentially every time a service gets started, everything a part gets started, the Istio system, let's call it, will inject the sidecar into every single part. And using IP tables, we're going to force all traffic through that sidecar. That sidecar now understands all traffic coming in and leaving that part. By understand, I mean can intercept that traffic and essentially can do some handling on that traffic, plus can also do the observability piece, plus can also do all the load balancing and everything else that we just saw in the previous slide. The other thing that it does is when two services connect to each other, they will be connected over mutual TLS connection. Every sidecar gets injected with a certificate representing the identity of that service. How do we present an identity into a certificate? With a little thing called SPIFFE, right? So we inject a SPIFFE header into each and single certificate. Well, we add it, and it's being loaded into memory. Who understands and knows SPIFFE or Spire? I won't be this is not the goal of the talk today, but SPIFFE and Spire is essentially a way to add an identity to a service, to an instance, to something that's calling something else. And how do we do that? By adding a unique identifier to that certificate that represents that service. And this can be done based on, in this case, a service account. But on public cloud can also be done based on IAM role, for example. There's multiple ways to include a SPIFFE into a certificate. But let's not talk about that today. Cool. In short, service mesh does service discovery, secure service-to-service communication, traffic control, service resiliency, and has an API programmable interface, which means CRDs, right? So essentially, the goal of all of this is to be able to manage my complete application networking using CRDs, so in a GitOps-friendly way, right? So this is what we want today. GitOps, a new buzzword. We all platform engineers today, or at least we think we are. So now, challenges with Sidecar. Also, it requires you to inject something into a pod, which may consume memory, will consume memory. What about startup sequences? Maybe you do have an init container there, and maybe that sidecar can stand in the way of that pod starting up. Jobs, how do you handle jobs, etc. This is one of the reasons that, I'll go ahead, that the community has developed ambient mesh. So Istio was launched around 2017, and then evolved to ambient mesh in 2022. Obviously, it was graduated to CNCF in 2022, and then later on, we launched, or at least the idea of ambient mesh. Ambient mesh is not production ready yet. I think somewhere early next year. Solio will probably have a version of it somewhere at the end of this year. But essentially, ambient mesh is in the making. What is ambient mesh? Everything I just told you, but with no sidecar. So I could have started with the explanation with no sidecar, would have made your life way easier. Um, so I could have just started with this one slide, but essentially, remove the sidecar. Essentially what we did, instead of having a sidecar per pod, let's have a proxy per node, right? So essentially what we did, I jumped ahead. I'm going to talk eBPF first, apparently. Sorry. So I'm going to change my slides around. Sidecarless comes afterwards. But how does eBPF plays a role with the sidecar model? And Liz touched on it earlier on. When two applications talk to each other, they pass via the sidecar. The sidecar passes via the network stack of your Kubernetes cluster over the environment that you connect to, and will obviously traverse and go to the other socket and then connect to the other proxy. And like that, it will connect between proxy. And essentially, it will need to traverse. I promise I won't talk through all of this now. But essentially, if you took, Liz talked about the pure network stack Kubernetes, but add Istio on top of it, and you got quite a complex route to connect two applications to sidecars to each other, right? So essentially, if you want to take a picture, please don't examine me about these slides, I promise I. But essentially what we do here with eBPF is take that packet, and instead of having it passing via that network stack, obviously, we pass packets in between sockets, right, in between kernels. So essentially, we heard from Liz earlier on, what is eBPF? Stands for Extended Berkeley Packet Filter. I know it by heart. But as I said, forget about it. So essentially what it is, it's event-based, right, in this case. Some events can be, as Liz showed, file events, etc. But some other events are networking-based events. And these events are based on hook points. So essentially what we're going to do, we're going to detect a certain networking event, and eBPF can detect that event thanks to a hook point. And then a certain kernel function can be executed based on that hook point, right? eBPF are designed to be safe, right? We made sure that it doesn't crash the kernel. It guarantees the return. So when an eBPF program gets loaded, it's going to make sure there is a verifier that's going to make sure that eBPF program is not going to run endlessly, that it's going to return at some point, right? So then some of these stuff are stuff that eBPF will take care of. Again, this is a very high-level architecture of eBPF. So essentially, you got the kernel program, which is everything that runs on the kernel that's going to take the information in, so all the packets that come into the kernel, do a verifier, so verify the kernel program, make sure that it has no mistakes, that it's not going to run endlessly. It's going to do a just-in-time compiler, meaning it's going to transform these bits and bytes into kernel programs. And the maps is an important thing, because the maps make sure that we can actually pass on information in between two eBPF programs. So this is also we pass packets in between two sidecars. So how does this apply to, and I'm going to pass this on, to sidecar acceleration, as we call it. So instead of passing via the network stack, we now pass via the socket of each application, kernel socket, or we pass that application directly to the other socket of the other application. So instead of passing via network stack, that very complex picture I showed you earlier, we just literally lift and shift the packet from one socket to the other. That's as simple as I can explain it, right? So essentially heavily accelerating that network stack. And cool. This is where we talk about ambient mesh. So we talked about sidecarless, so sidecars with eBPF and how we can accelerate that networking connection. Next is, let's try to do service mesh with no sidecars. So as I mentioned, so Solo.io and Google decided together, let's build something cool. Let's remove that sidecar from Istio. And obviously it's been donated to CNCF, but sidecarless Istio is going to be a fact, or is a fact. You can test it today if you want to play around with it. It will obviously have a heavy cost reduction because no sidecars. It's simplify operations because you don't have all these sidecars, versioning of sidecars, etc., to take care of. So if there is a new version of Istio, you'll have to just update, we'll see later on the proxy, the node level proxy, which will be high available, so there's going to be no downtime. We'll have no sidecars to update, so no paths to restart. You won't have to do all of these things. Cool. So essentially, as I mentioned, we moved the proxy from paths to a node level proxy. We call it, Istio calls it the Z tunnel. The Z tunnel is essentially a proxy, a layer 4 proxy written in Rust, right? So it's lightweight and quite performant. And essentially, it's reduced computing costs, it's simplified operations, and for the application team, it's completely transparent. There's nothing getting injected, there's nothing being done there. Essentially what happens, we use a CNI plugin, let me put it that way, chained CNI plugin, to be more specific. So we use the existing CNI, and we force all traffic coming from a path through that node level proxy. Awesome. So, as I mentioned, the node level proxy is a layer 4 proxy. And very similar to what Cilium does on layer 7, if and when you want layer 7 processing, you need a layer 7 proxy, which is based on the Envoy Gateway API as well, right? So essentially, if you want a layer 7 processing with ambient, you need to deploy a waypoint, as you call it, a waypoint proxy, which will handle the layer 7 routing and layer 7 policies for Istio. Awesome. Cool. I'm going to skip that. So let's look at some numbers. Also really bad at numbers, so I'm going to look at the slide. So this is a test that we did. 31 parts, 31 sidecars, obviously 3 nodes. So there's 3 ambient nodes, 3 ambient proxies. We saw the total CPU time went from 3.1 virtual CPUs to 0.3 virtual CPUs, which is quite a big win if you think about it. 0.3 per sidecar, that's being said, right? Total memory obviously went down quite a bit, right? And obviously, if you do a layer 7 proxy, it adds a little bit on top of it. But the difference is huge, right? Went from having to manage, in this case, 31 sidecars to just being the need to manage 3 node-level proxies, and eventually some layer 7 waypoints in the middle as well. Awesome. So, as I mentioned, Istio sidecars, traditionally, they do MTLS between 2 paths, as I mentioned. So there's Envoy making connection between 2 paths and doing the MTLS connection. With Z-tunnel, with ambient, essentially that MTLS happens between nodes, okay? So between one single node, within one single node, you'll have normal connection. But as soon as that connection leaves that node, it's going to create an MTLS connection in between these 2 nodes. So I'll answer the question, what if I do want MTLS within a node? Well, then you inject a sidecar. Okay, so it's not the ideal answer, but if you do want that MTLS within a node, I repeat, you can mix and match both models, okay? Awesome. So, just to repeat, so Z-tunnel is a layer 4 secure overlay layer, right? It will do traffic management, security, and observability, right? Everything above layer 4, so to layer 7, needs that extra waypoint. Cool. This is a bit of a more technical representation. As I mentioned, as soon as the traffic leaves a node, it's going to do MTLS connection between these nodes. And behind this, we implement something called HBone. Anybody familiar with HBone? Yeah, I wasn't either until a few months ago, to be honest. So essentially, HBone is an HTTPS overlay, which I'm going to explain in a second, that can guarantee the identity in between 2 applications. If C1 calls S1, for example, when C1 gets to S1, we still know it's C1, thanks to, again, one of the things we do there is SPIFFE, right? So we inject a spiffy header, and we know that when the application traffic gets to the other side, we still know, hey, it's still me, okay? Awesome. I talked about waypoints. So essentially, if there is a layer 7 policy in place, what needs to happen is, thanks to CNI, as I mentioned, I force the traffic through that Z-tunnel. The Z-tunnel then knows, oh, I need to do a layer 7 policy there, maybe a header-based matching or whatever, or not a layer 7 authorization policy or something like that. In this case, the waypoint proxy is needed. So the Z-tunnel, we're going to forward that connection to the waypoint proxy, and if it goes to another node, the waypoint proxy is going to connect to the Z-tunnel on the other side and make the connection. This is where I talk about Edgebone very quickly. So Edgebone, as I mentioned, is an overlay that allows to connect two tunnels to each other, all by guaranteeing the original identity in between the two endpoints. So as to repeat, if two applications connect to each other between two nodes, passes over that Z-tunnel, thanks to that Edgebone overlay, we can also, first of all, guarantee security. Secondly, can guarantee that identity in between these two endpoints. What about Cilium? Do you want to talk about it? Just kidding. So, what about Cilium, right? I can't be talking about agentless or sidecarless without talking about Cilium, of course, right? There's no way around it. So, what is Cilium? Well, I'll ask a stupid question. Who knows Cilium? Okay, people listened, right? So, Cilium is an open source software. Is essentially it's transparently securing the network, thanks to the fact that Cilium is also CNI, right? And Cilium, as Liz correctly introduced, is based on eBPF, right? So it implements out of the box from the CNI on security visibility, and it enables you to control the logic and the routing between applications and so on. The way it works is because Cilium, as I mentioned, is an eBPF-based CNI. So the way this works, when an application calls another application, it's going to do a syscall called BPF. The syscall is going to intercept, thanks to that hook that I talked about, that networking, right? That application is going to be loaded, of course. And essentially, thanks to the BPF map, we're going to be able to also pass on information in between two sockets. That eBPF is essentially a key value store, right? That holds information of a certain running process, and it can pass on information in between two processes. So essentially what Cilium is going to do is, based on the eBPF, being able to pass on information from one socket to the other based on eBPF, as I mentioned. Cool. Cilium, also, the way that Cilium works, of course, it's eBPF-based routing, and thanks to Cilium agents, it can also route traffic in between nodes, right? So very similarly to what we saw earlier, and also implements routing, telemetry, and so on. So Cilium is, as I mentioned, a CNI-based networking, CNI-based service mesh that is heavily relying on eBPF. Who wants to see ambient? I hope it works. 5 minutes. This is the last slide anyway, so I won't need much time. Awesome. Cool. Who knows Instruct? Yeah. Nobody knows Instruct. Oh. Anyway, so I use Instruct here, which is a preloaded lab. So essentially, oh, I need to restart this one here. So if I do, is this small? I need to zoom in probably, right? Cool. If I do, awesome. So I see these different applications running, right? And in a normal, in Istio, I would need to add a label on the namespace or on the path, on the deployment for that path to be injected. What I'm going to do, however, I'm going to add another type of annotation, which is data plane mode equals ambient. As soon as I've done that, the daemon set that is running is going to intercept it, and we're going to see that it starts to, and I'm going to do up. It's going to be here. So ambient mesh, you see that it automatically enables ambient on the namespace, and it's going to add part to the ambient networking as well. So you see automatically by adding this annotation, it's being intercepted, and automatically we can start implementing some of these policies. Awesome. There's a lot of text there. Okay, let's generate some traffic just to see that that node level proxy has information about everything that passes on. You see, there's inbound connection and outbound connections. Everything's being intercepted by that node level proxy. Awesome. Now, let's test an authorization policy just to show you, okay, it's very similar to, it's an Istio authorization policy, right, that I'm going to implement. So let me just store that IP here. So first, I'm going to curl that application, Istio explain.io, and I can see, okay, this is working. I'm now going to implement an authorization policy that essentially denies everything. And just to show you I'm not lying, no sidecars. We agree there's no sidecars, right? So now I've implemented this, and if I call this connection reset by peer, you see, allow nothing. There you go, and it doesn't allow me to connect, right? Sorry, it was. So that means that now based on, it's actually the node level proxy that is making that is blocking that traffic essentially, okay? I'm going to now add a new authorization policy that allows me to do that traffic, okay? And if I curl this, I can see it works again. Let's quickly go 1 minute. I have, right? We've got 3 minutes. Let me show you the waypoint, the layer 7 proxy, right? So with the layer 7 authorization proxy, the first thing I'm going to do is deploy a gateway, right? So using the gateway API, and it's being rolled out. Now that I have that gateway deployed, right, up, let's see that it's been deployed correctly, awesome, right? And now I can have an authorization policy that allows only the operations get. Awesome. Now, if I test, here you go. This works, right? But if I try something that is not get, obviously this being blocked, nothing happens, right? So if I do minus, you see it's being here forbidden by the Istio envoy, right? So essentially what we did here, we know, so essentially that information passed by that waypoint proxy, that waypoint proxy denied the connection and blocked the destination, right? Up, if I send a delete request here directly here, you see it, as I mentioned, it doesn't work. Awesome. The last one, and I'm going to skip this one, is I usually show a, if I want MTLS within a node, I just inject a sidecar, exactly the same as I would with normal Istio. As a quick summary, go back here. eBPF is here to stay, at least I think, right? I don't have a crystal ball. Sidecarless will the most common way to deploy service mesh. I think we agree on that one. Sidecars will stick around for some use case, at least with Istio. Cilium will be default data path accelerator for container networking. Service mesh will cover all the L4 to L7 networking needs. And we didn't cover it, but integrated with the Cloud Native API gateway will be important in the future to give you access to that secure application secured by the service mesh. There you go. If you want to learn more about Istio, open source Istio, etc., we have, or you can reach out on Slack. We also have on Solo.io a bunch of materials you can use to learn about Istio and get certified. And with that, thank you very much.
All right, thank you. Perfectly right on time. If you have any more questions, Jona will be around the stage or downstairs, I assume.
Yeah.
The next talk will happen here at 11 a.m. It will be about container security. Yeah, see you right here and enjoy the break.